Hello. So this is my my office we're in at the moment. So yeah, I never thought I would be doing this, but anyway, let's see what happens. So I'm going to change my welcoming message to kind of a more upbeat message, and let's keep washing hands, okay? So keep washing hands, guys. So now let's do some sums. The first thing we're going to look at is going to be a new topic. So we've finished arithmetic. I sent you out a test. Well done to those who did it. I haven't marked it yet, but we'll see what happens with it. Now, the new topic we're going to study is called complex numbers. So we'll just write that up and we'll see what happens. So complex numbers. So that's the topic that we're going to be studying for the next fortnight or so. So I might be seeing you on the 30th, but probably not. So this will probably be the format it's going to be in. I'm going to try and get myself a blackboard as well on this brown paper. But yeah, what you need to be aware of at this moment in time, we are studying complex numbers. So I think normally when a teacher introduces this concept of complex numbers, students become a little bit panicked because complex has two meanings. Complex means something that's difficult or something that's hard. But complex, in a kind of more traditional sense, means something where there's more than one part to it. And so if we had, let's say, a complex of buildings, so there might be a leisure complex. And a leisure complex, there might be bowling, there might be quasar, there might be a gym, there might be a restaurant. So in a leisure complex, there's more than one part to it. So it's a complex, more than one part. So complex numbers are going to be that understanding of complex. It's not complex as in difficult. In fact, I think these things are quite nice and they're quite easy, okay? But it's just that there's more than one part to these numbers, okay? It's a topic that is going to suffer immensely because of the language we're going to be using, but we're forced to use it because these are the words that everyone uses. So complex numbers, basically numbers where there's more than one part. So we now need to think about where does that second part come from? If I gave you the number, let's say 2, yeah, that's a perfectly good number. We all know that's a number, nothing weird with it whatsoever. Yeah, so that's not a complex number currently. Well, technically it is, but let's say that's just a real number as it currently stands. So let's take a look at how a complex number would arise. So that would be a real number. And so let's take a look now at how these complex numbers arise. So I'm going to get you to do some maths now in a moment. So can you guys have a go at solving x squared minus 6x, I think it's plus 11, is equal to 0. So can you guys have a go at solving that for me now? And maybe to get you started, I might just take a look at what type of equation this is. So this is so this is a quadratic equation. And if we want to solve quadratic equations, we're going to use what system? Good. So we're going to use the minus b system, or the minus b formula on this thing here. So the minus b formula looks a bit like this. X will equal minus b plus or minus the square root of b squared minus 4ac all over 2a. So it's BBACA. And I'll just put that in for you. You can rewind anyway, that's the beauty of this thing. It's BBACA. It's in your maths tables as well. So we're going to solve this quadratic equation using the minus b formula. So put in the information and see what the answer is. Don't worry too much about it. So have a go at that now. Okay, so you guys can obviously pause it. So I'm just going to jump straight into it now. And pause it now if you want to have a go at it yourselves. So b, for me, is going to be minus 6. B is going to be minus 6. A is the guy in front here, that's technically a 1. That's going to be an 11, and that's going to be a 1 also. And I can put that straight into my calculator. Let's see what happens. So I hit the fraction button first of all. Fraction, and then it's minus on top, bracket, minus 6, close bracket. We take the plus one first of all, square root, start bracket, minus 6, close bracket, squared, minus 4, open bracket, 1, close bracket, open bracket, 1, 1, close bracket, all over 2, open bracket 1, close bracket. And that should give us, oh, math error. Did that happen for you guys? Did you get math error as well? Yeah. So math error, that's kind of unusual. And normally we would panic when we see that. It means we probably got our signs wrong here or something, but no, we did it perfectly. We got math error. So yeah, so maybe that's where this other complex number part comes from. So yeah, let's run with this and see how far we get. Okay, so I'm going to do some stuff here, just make this a little bit neater. And so let's see what happens. So I'm going to get rid of him. I'm going to tidy this up. So minus 6, that's just 6. Plus or minus, okay, minus 6 squared. Minus 6 times minus 6 is going to be 36. These are all inside a square root. 36 minus 44. And that's all over 2. And we're getting closer to where we need to be to see this second part occurring. So that's going to be x equals. And then we have, excuse me, oh, hope everything is okay. So that's going to be 6 plus or minus 36 minus 44. 36 minus 44, that's going to be minus 8. And that's all over 2. And so we're doing quite well now. And this 2, because this line goes from that side of the fraction all the way over to this side of the fraction, this 2 is dividing into both of these things. So this 2 is dividing into the 6, but it's also dividing into this root of minus 8. So let's take a look at that. So when we divide the 6 by 2, we get 3. So x is now equal to 3. But 2, well, that's the same thing as the square root of 4. So that's the same thing as 6 plus or minus the square root of minus 8. That's all over 2. And I'm going to put this guy here all over the square root of 4. So the square root of 4 is exactly the same thing as 2, right? Yeah. So that's going to be 3 plus or minus. So we're going to have the square root of 8, the square root of negative 8 divided by the square root of 4. If you put that into your calculators, you should get this thing here out. It's going to be the square root of minus 2. And all that's happening there is we can put this over one big square root sign, and we 4 divided into minus 8, so that's going to give us minus 2. And then, so let's take a look at where this math error is occurring. We can put that into our calculators now and see what happens. So square root of minus 2, what do we get out? So that's where the math error is arising from. So this thing here is causing us problems. This part here, the calculator can deal with that, no problem at all. This thing here, that's causing us issues. So we need some way of dealing with this. And the way that we deal with it is whenever we have the square root of a negative thing, okay, well, we introduce a new number. So there's a new number that you guys previously had never seen before. New number. Okay, so you will never have seen this number before. Maybe you have, but highly likely that you haven't. So the new number, and the new number is the number I. Okay, so that's a new number, it's I. That's okay, yeah, that's all the new number is, it's just a new number I. But we can assign a value to this new number, and we assign the value, now, you guys are doing ordinary level, so I'm going to write up something here that I wouldn't write up at higher level. So if you happen to be looking at this for my higher level class, you need a different way of approaching this. But for ordinary level, we're going to do this. So I is equal to the square root of minus 1. More correctly, we should really write I squared is equal to minus 1. But for us, we're going to leave it with I is equal to the square root of minus 1. So that's what we understand I to be. I is equal to the square root of minus 1. So I can go back up here, and I can write this line up here again as x is equal to 3 plus or minus the square root of 2 multiplied by the square root of minus 1. So I'm multiplying the square root of 2 by the square root of minus 1. And just like I could combine the square roots here, I can combine the square roots here to be a product. So 2 times minus 1 is minus 2. So everything is good. So that's all fine. And I know that the square root of minus 1 is the same thing as I. So I can turn that square root of minus 1 into an I. So we can now write x is equal to 3 plus or minus root 2 and then I. So we're multiplying root 2 here by I. Now, let's get back to where this topic came from. This topic comes from complex numbers, and what we see here is a complex number because there is this part, and there's also this part back here. Okay. We've seen from over here that we just call numbers like this real numbers. The numbers you had before you started studying this topic were the real numbers. And so that's a real part. That's a real part. And there's also this thing here. Crucially, it has to have an I in it to be the second part. So crucially, it is I for, again, the language is appalling. Don't worry too much about why it's called this. It's just called the imaginary. Imaginary part. So we have the real part, and we also have the imaginary part. And that's why it's complex, because we have a real part and an imaginary part. So that's the first complex number that you guys have seen. The first imaginary number that you guys just saw a few seconds ago, for you, for me it was this big paper change in between, but for you the first complex number you saw was this complex number here. And it was the number, I think, 3 plus or minus the square root of 2i. And just to recap really quickly, that was the real part and that was the imaginary part. There's actually two numbers in here, right? Because we have a plus or a minus. Okay, so we have 3 plus root 2i or 3 minus root 2i. I probably should have sorted that out beforehand, but just be aware that there's two complex numbers here, the 3 plus root 2i and 3 minus root 2i. What you guys need to realize is, now this is the real part, this is the imaginary part of those complex numbers. Because I don't like dealing with square roots and carrying square roots around, I'm now going to get rid of this complex number. Let's call that complex number, in fact I won't call it anything, okay? I'm going to introduce a new complex number, and this new complex number is going to be called Z1. Z1, and Z1 equals 3 plus 2i. So it's nothing to do with this guy up here. In fact, I'm going to cross this out into a box. So we're no longer dealing with this complex number. I'm now going to be talking about this complex number here. And I'm calling that complex number Z1. And so the question I would now ask is, why is this a complex number? So think about that. Why is this a complex number? Good. Because there's this real part and there's this imaginary part. So when we have two parts to a number, it's a complex number. It's a number with more than one part. So this is a complex number. Now, I've done an awful lot of talking about why it's complex, but I haven't really done much talking about number. So I'm now going to spend a little bit of time about number. And I want you to think back to when you guys were in primary school, maybe even in first class primary school, and you were given your numbers. And you might have been given the numbers 1, 2, 3, 4, ... all the way up as far as 20. So you would have been given all of these numbers here, 1, 2, 3, 4, 5, 6, 7, whatever, all the way up to 20 or something. And they were your numbers. And with these numbers, you learn to do certain things with them. So normally for this lesson, I would ask for brainstorming about what we got to do with our numbers when we were in primary school. Can't do that here, obviously. So just think about that for a second. When you were given your numbers, there's your numbers. What did you then start doing with your numbers? Yeah, okay. You would have added them. You would have subtracted them. You would have multiplied them. You would have divided them. And you would have plotted them. So on a number line, you would have come along and you would have said, that's the number 2, that's the number 3, that's the number 4, that's the number 20. On a number line, you would have plotted these numbers, okay? So realistically, this entire chapter is like we're back in primary school and we're after giving you a set of new numbers, the complex numbers, and I need to teach you and you need to learn how to add them, subtract them, how to multiply them, how to divide them, and how to plot them. And if you can do that, you will be flying for your Leaving Cert. Okay? So you need to be able to add, subtract, multiply, divide, and plot. That's really it. Okay? At higher level, it's a bit more trickier, but at ordinary level, if you can do that with these numbers, good. So let's take a look at how to add complex numbers. Complex, oh. So loads of students panic when they start seeing complex numbers because of the word complex and because of the word imaginary. Don't fall into the trap, guys, of being a moody teenager and thinking, oh, this is imaginary, that's ridiculous. I'm a 21st century teenager. I have better things to do with my time than dealing with imaginary numbers. Okay, these are not really imaginary numbers. These are just the number I. Okay, it just stands for imaginary. It could just as easily stand for interesting or indigo. Yeah, it's just a symbol. Okay, and it happens to stand for imaginary. Don't be too concerned about why we use that word imaginary. Okay, so we're now going to start doing some sums on the complex number. Specifically, we're going to look at addition. So we could add Z1 onto Z1, it'd be very boring. So let's add Z1 onto Z2. So Z2 is going to look like 5 plus 4i. Did I pick bad numbers there? I'm always wary. No, I didn't. I'm good. Okay. So Z1 is this guy and Z2 is this guy. So I'm now going to write out Z1 plus Z2, and that's going to equal 3 plus 2i plus 5 plus 4i. So you probably know what to do here anyway without me even talking. So maybe think about that for a second. What do you guys think the answer to this thing is going to be? Yeah, very, very good. It's equal to it's this part here being added onto this part here. So we can add the real parts together. So that's going to give us 8. And we have 2 i's here, and we have 4 i's there. So we can add these two together, and that's going to give us 6i. So when we add this complex number onto this complex number, we get this number here. Is that number a complex number? Yeah, because it has a real part and it has an imaginary part. So that's a complex number. So we've made this complex number through the operation of addition. So there's really no teaching there, right? Addition just works like you would assume addition to work. You can add the real part onto the real part, the imaginary part onto the imaginary part. A bit like these were numbers and these were x's. It's a bit like that, okay? Don't get too latched onto that system, but we can add real parts onto real parts, imaginary parts onto imaginary parts. Nothing too bizarre there. Let's take a look. That's easy, right? Really, really easy. Yeah. Okay, let's take a look at, so I can put a big tick on my, sorry. Okay, so I can put a big tick on my plus. So I've dealt with him. So now what's going to happen? I'm going to do some subtracting. So I'm going to go for, do you know what? Let's get some negatives into this process. So let's go for Z1, take away Z2. And that's going to equal, you probably have never seen me writing the letter Z before, and I write it like a maths teacher writes their Z's. So I'm putting a line through my Z's to make sure I'm not getting mixed up with 2's, the number 2. The number 2 there looks a little bit like a Z. So to make sure I'm not getting mixed up with my Z's and my 2's, I put a line through Z's, okay? Don't be too concerned about that. So I'm now going to go with Z1 take away Z2. So I have 3 plus 2i. Now I need to be really, really careful here. So I'm going to put in a minus. But both of these parts, not just the 5 plus the 4i, both of those parts, the real part and the imaginary part, have to be taken away from this number here. So to show that this minus is acting on the entire complex number, I'm going to write 5 plus 4i. Okay, so I'm taking this complex number away from this complex number. That complex number is Z2, and that complex number is Z1. I could put him in brackets if I wanted to. There's no real need, so I won't. Ink is very, very expensive. Now, next job, Z1, take away Z2 is equal to, okay. So, just like over here, we can add the real parts onto the real parts. What do you think I'm going to do here? Yeah, good. So I'm going to take the real part from the real part, and I'm going to take the imaginary part away from the imaginary part. We might be happier just taking one more step, and that's going to be 3 plus 2i minus 5 minus 4i. I know some of you guys, it drives you mad when I start putting in all these little intermediate steps. Yeah, I think it's worthwhile doing the first time anyway, okay? Just to make sure that this plus here doesn't get mistaken to be a plus on the 2i. Okay, this minus is hitting both of these things, so we're going to put a minus in front of both of them. So that's going to give us, now, Z1 minus Z2 will equal 3 take away 5. Well, 3 take away 5. 3 take away 5. So I'm at 3, I jump back 5. It's going to give me minus 2. 2i take away 4i. I'm at 2i. I take away 4i. If I take away 2, I get to 0. That's going to be minus 2i. Ooh. Okay, so probably a bad teaching example, but anyway, it happened. So the real part of this is minus 2. The imaginary part is minus 2i. So that's how we do subtraction. We take the real part from the real part, the imaginary part from the imaginary part. Okay with that? So I can now put a big tick on top of the subtraction. So we're now flying through first class primary school with our new numbers, and we're now doing some multiplication. So let's take a look at how we're going to multiply Z1 by Z2. To show that we're multiplying them together, we write them together like that, and that's going to equal, so that's going to equal 3 plus 2i times 5 plus 4i. So we're multiplying complex numbers. Now, this was all very easy. This was all very easy. This is really, really easy. There's just a little bit of a trick at the end, okay? So there's just something that we need to be aware of at the end. So this is going to work exactly like you probably think it's going to work, and then just look out for something at the end. So let's multiply this out. I'm not going to write all these out again, I'll just put an equals there. So this equals means that it's equal to that, and this equals means it's equal to that, and, yeah, and so on and so forth. So To multiply this thing by this thing, well, each thing in here has to multiply each thing in there, so it's going to be 3 by 5 is 15, 3 by 4i is 12i, 2i by 5i is 10i, and 2i by 4i is 8i squared. You guys are good at that sort of stuff, so we end up with this thing here. I can type that up. I can go 15 plus, now that's 12i and that's 10i, so together, when I add those two together, it gives me 22i. And then we have plus 8i squared here. Now, let's cast our mind back to when we were introducing this topic. Can anyone remember what I squared was defined as? We said I squared is equal to, we said it's equal to some value. Remember I wrote down, I don't know if you can see this over here, but anyway, I wrote down that, I'll do it up here. Remember I wrote down that I squared, I by itself is equal to the square root of minus 1. And I also wrote down I squared, because of this, what's I squared equal to? Yeah, so I squared must equal minus 1. I'll put that into a little, maybe a cloud floating away above us all. Okay, so that would suggest that this thing here, I should rewrite that as minus 1. So that's going to be plus 8 being multiplied by minus 1. Now, what's going on here? Plus 8 by minus 1. Plus 8 by minus 1. Nothing really is happening here yet. Plus 8 by minus 1, that's just minus 8. So that's going to equal 7, is it? Yeah. Plus 22i. So, I say so far too often. The product Z1 times Z2 is equal to 7 plus 22i. This line here, you knew how to do that. I'm pretty sure you know how to do that without me even talking. And the little trick I was talking about is in here. Is this I squared. When we're multiplying this thing by this thing, we will always end up with an I squared. When we multiply the imaginary part by the imaginary part, there will always be an I squared term. And that I squared always gets turned into minus 1. And that gets an extra real part that we can combine with this real part here. So we've looked at adding, subtracting, we've now done multiplication. I'm probably going to leave division and plotting until the next day. So I'm now going to park it there. You've seen an example of how to add, how to subtract, how to multiply. You have a fair idea where complex numbers come from. So I'm now going to look in the textbook and see if I can get some exercises for you guys to do. And we can now answer page 191, question 2, 4, 6. On page 192, we can answer question 2, 4, 6, and 8. So if you want to have a go at those questions, today or over the weekend, you guys have maths again on Monday, so I'll put up some solutions on Monday and we'll move on to division and maybe plotting. Division is going to take us quite a long time, okay? Division is really where the hard stuff in the chapter is, okay? Again, it's not particularly hard, it's just longer. We won't be able to do 3 in one day, okay? So it's probably going to be division the next day. Just to recap, complex numbers come from having two parts to a number. There's the real part and the imaginary part. And this imaginary part comes from this idea up here, where I is equal to the square root of minus 1, or more correctly, I squared is equal to minus 1. And we then moved on to how to add them, how to subtract them, how to multiply them. To add them, we add the real parts to the real parts, and the imaginary parts onto the imaginary parts. To subtract them, we subtract the real part from the real part, and we subtract the imaginary part from the imaginary part. To multiply them, well, we multiply them out like we would any other kind of binomial or two things multiplying two things. So two things multiplying two things here, that gives this line here, and we need to do a bit of tidying up. And the big piece of tidying up we need to do is that there will always be an I squared term, because we're multiplying the imaginary part by the imaginary part to give us this I squared, and we need to remember that I squared is always equal to -1. So once we remember that, we're flying. So have a good weekend, and I'll see you on Monday. And keep washing hands.